exploratory data analysis using Python. The main application I'll be using for this course is Python, but I'll be running my Python on the Jupyter IDLE. You can get your Jupyter IDLE from Anaconda by downloading Anaconda, or by downloading Anaconda. Anaconda is available for both Windows, Mac, and Linux. So once you download Anaconda, you see your Jupyter notebook in there. Or you install Python by visiting python.org. After installing Python by visiting python.org, from Python you can use pip install to install Anaconda. You can use pip install to install Jupyter Notebook and other libraries that you need. So for now, let me start by running my Anaconda using the command prompt. Alright, I'm using the command prompt here, so it pops up, and then I go Jupyter Notebook. So the command prompt does some backend work while trying to bring up my Jupyter Notebook in my browser. But before I go, I have a message for everybody from one of our sponsors, and it's going to be very short. So this, I'm holding this. This is actually very important. This is life itself. It's important to life, right? And I'll drink this, and after drinking this, you see what happened. My voice will change, my aura will change, and everything will be fine. Let me drink this. Wow, this is pure water. Drink pure water today. Ensure you drink pure water every day. It's very, very important. Alright, those are our sponsors. Pure water from Nigeria. Drink pure water every day. It's good for your health. So let's get to it. So my Jupyter application is up. It opens in the browser. It opens in your default browser. So let's get to it. I'm going to be showing you two things on this page right now. I'll be showing you first how to create a folder in Jupyter so that you won't have your files just scattered around. You want your project to be in a place. Whatever you're outputting from the project to also be in that folder. You want your files, your CSV, your Excel, whatever files you're working on, you want them to be in this folder and other stuff like that. So you have to create a folder for whatever project you want to work on, and after creating this folder, then you create your other Python notebooks inside this folder. So let's get started. So first thing is, I'll be creating a folder. I'll click on new, and then I see folder. After I click on folder, nothing happened, but when you scroll down, you see Python folder. Sorry, you see untitled folder. Now this untitled folder is a new folder that has been created, and if you open it, you realize it is empty. If you open this folder, you see it is empty. So now I'll go back and rename my untitled folder. And how do I rename it? I check the box beside the untitled folder, I scroll back up, I see rename, I click on rename, it brings this. So yeah, I type whatever name I want to give it. So I'm going to call it my name. Yeah, I'll call it my nickname. My nickname, they call me Santini. So I'm calling it Santini, then I rename. I click on rename. Now you scroll back up and you realize that yeah, we have Santini here, we have Santini here, this is Santini, and it is empty. So inside Santini is where I want all my files to be, all the files I'll be working on when I want to. All the files I'll be working on while I'm working on the Santini project, right? So more or less like this is a Santini project folder. And it's also going to make it easier for you to export this to GitHub, because you can just commit this folder itself, and it is going to be online, and if you want anybody to see it, you can make them see it. If you don't want them to see it, you can make them see it. That's another story for another day. All right, let's get to it. So now we've created our folder. Secondly is we come here and we click on new. Now we click on new, we see Python 3. You click on Python 3. Python 3, a IPYNB notebook or a IPYNB file is going to be created in this folder once this Python 3 notebook has been loaded successfully. So the IPYNB extension, IPYNB stands for IPython notebook, and we'll see why it is called I. I stands for interactive. I don't know why this is taking long. It shouldn't take this long. All right, so it's up. So it's called it's an IPYNB notebook, which you can see from here, IPYNB, right? As you can see, the extension is IPYNB, which stands for IPython notebook. But then we'll see why it is called IPython in a second. Now this is a notebook, and you can rename your notebook by clicking on this untitled that is written just beside Jupyter. You click on it, and I want to call it Santini 1, right? Santini, no, I want to call it Upendo, so I call it Upendo. I call this notebook Upendo. So I click on it, I tapped enter, or you just click rename and it renames. Then yeah. Now it is called IPython because you can say 2 plus 2, and when you run this cell by clicking run, it outputs 4. So it is interactive in the sense that you give it an input, it gives you an output directly. No need for you to take it to the Python, write the code in your notepad or whatever file, whatever application you want to use to write your code. Then you import it into Python to run the code, and when there's an error, you now need to go back to it. No. This is interactive, and it gives you the opportunity to debug as fast as possible. So no need for you to be running up and down looking for what is not missing, right? So let's get to it. This is not the aim of this. The aim of this video is to give you an overview of what exploratory data analysis is about, and let's get to that fast as possible. So I go back to my Santini folder because I already created a folder and a notebook so that this whole session and explanation is going to be faster. And I think I named this the folder in Learn Tutorials. Yeah, I did. So I click on this, which is my notebook that I've created, and this notebook is what we are going to be working with all through this session. So shit is about to go down, and believe me, all the codes that are in this notebook are also very simple. There will be a link for this notebook online, and also the dataset that I will use while running this notebook. A link will also be given down below, just under this video. You can click on it and download the notebook. So let's get to it. What is exploratory data analysis in the first place, right? Exploratory data analysis is you trying to explore, just as the name depicts, explore. You're exploring your data. You don't know where your data is. You just got in the new data. You don't just want to jump into it and put it into scikit-learn and start running machine learning algorithms. Oh God, I'm saying so much rubbish already. So you don't want to start doing predictive analysis. You don't want to start building models on your data already. So first thing you want to do is you want to look at your data, understand your data, know what each column stands for, know what type of data they contain. Is it numeric? Is it categorical? Or is it even numeric that has been called categorical? Or is it categorical that has been called numeric? Right. Before you can actually go through with this video and find it useful, you should have basic knowledge of basic knowledge of Python data types, and other basic knowledge like that. How to write simple Python codes, how to subset lists, and other basic stuff like that. So if you have this knowledge, then you are good to go. If you understand what I meant when I said categorical, if you understood what I said when I meant numerical, if you understood what I said when I meant strings or booleans, then I think you're good to go. So let's get to it. So the first thing we want to do here is we want to import the required packages, right? Which I have done here. So I import pandas as PD. Pandas, the popular alias for importing pandas is PD. I import matplotlib as PLT. I import Seaborn as SNS, and then I'm putting something in matplotlib. I added something in matplotlib notebook, but I think I remove it for now. So as to ensure that I don't run into some errors. Alright, so let's continue from here. So after doing that, I read my dataset, which is called autos.csv, and is already inside my folder. Just as I said, you want to put everything inside the folder, so it's already inside this folder. So I just run pd.read_csv, and I assign the imported file to autos. Right now, so then that is that. Let's ignore this for now. Right, let's ignore this for now. I clean that. Then I run this column. After running that, as you can see, it is running. So when your notebook is running, you see an asterisk beside it here, just like this one. And when it is done running, the asterisk goes away and you see a number, probably 1 or 2. Now, the first thing we are going to do after our notebook is done running after all what we want to import has been imported and likes, the first thing we want to do is to get the summary statistics and look through our data. Right, this is part of the exploratory data analysis. This is the first thing you want to do, and the best way for you to do this is by calling df.ed. Right, df.ed is actually not like the first thing. It's not like the first thing you should do or the last thing you should do, but it is part of the things you want to do because you want to see your data. You want to sightsee. You know, like more like you want to let's say you want to do window shopping. Yes, you want to do window shopping of your data because right now you are not probably ready to do so many things on your data. You just want to view your data and write things down. So while you are viewing your data, you should have a notepad beside you so that you can jot things down, things you want to do when you are doing your cleaning, when you are cleaning your data set. So right, let's get to it. The first thing is we do df.ed. So what I did here is df.ed. And what does df.ed do? df.ed is that takes in one argument, but if you don't give it any argument, which I did not specify here, it will give you the first 5 rows of your data set, and that is what it has given us. So, but then because my data frame is not df, so mine is autos.ed. If I have called my data frame here df, then I would have been using df.ed here, but I did not call it df, so I call it autos.ed. So now when you run this, you get the output that you can see down there, whereby you can see all your columns. But as you can see here, we have 3 dots here, which means that some things are missing, some things are in between that df.ed is not allowing us to see because of the length, because of the number of columns of the data set. We have 26 columns, but I don't think number of columns being displayed here, as you can see, is not up to 26. So equally we have dot tail method, which you can also call on your data frame, but my data frame here is called autos. So autos.tail, this gives us the last, if I don't put in any argument, gives us the last 5 rows of our data set. But let's assume I want to see the last 10 rows of our data set. All I have to do is come here and put the number I want there, 10. I put the number I want there and I run, and it gives me the last 10 rows of our data set. So let me put 10 here, 10, and I run. And as you can see, I'm having the last 10 rows of my data set been displayed to me. So that is how this works. Then moving on from there, basically this is very, very important because you see each column and you can see what type of data set it contains. For example, symbolizing is actually numbers, contain numbers, so you expect it to be numeric. Normalized loss is same, make ID is the same. But for type, you can see it is string, but we don't know whether it is meant to be left as string or should be converted to categorical depending on the amount of unique values that it contains. And likes, you can always look at the rest, but then we can't see some that are here. So to deal with that, we just have to come down here and we do df.info. Sorry, why am I saying df? Autos.info, since my data set is called autos. So we do autos.info. Now here we can see, for autos.info, we can see all the 26 columns, their names, and what data type they are claimed to contain, right? And whether they have missing values or not. Now the dataset itself said it has what? 216 entries. Autos.info is giving us this information that the dataset contains 216 entries indexed from 0 to 215. I believe if you've taken your beginner's course in Python, you should understand that Python uses indexes. That is, Python starts listing stuff not from 1, it starts listing them from 0. If we go back to our df.ed, realize that these columns are not named from 1, it started from 0. So that being said, I come back here and we get the opportunity to look through our data set, the columns, their names, whether they have missing values or not, and what data type they currently contain. Right, so let me run this df.info again so we can get some things right. So make ID is set to be an integer, normalized losses float, but then all these guys here are called objects. All these guys here are called objects. Now your machine learning algorithm doesn't know how to deal with texts. Most machine learning algorithm knows how to deal basically with numbers, so you don't want to have text there. So we'll look for a way to deal with it, either by using the natural language processing, or by converting them to numerical to categorical variables, and then doing the PD get dummies or one not encoding to get numerical values for each of these columns. Right? Then we'll move on from there. But right now we can actually see what our data contains. So I just do autos.column to get the name of the columns. Now why am I doing this? It's just to ensure that the names of our columns are well spelled and that we don't have spaces in places we don't want spaces to be. This can actually be troublesome. So I move on to the next one. Yeah. So what I did here is I just want to be sure that that those objects columns, right? These columns that has been called objects, I want to be sure that they are not meant to be categoricals, because if they're actually string, it means you have a long process to go in converting them to numericals. But if they are categoricals, it means you can just take 2 steps and then we're done with them. So first thing first is I write this function. To check if a column is meant to be categorical or not. And how is this going to check it? Because it is going to check by returning the number of unique values that each column in our dataset contains. So this function that I created called uCount takes in 2 arguments, a data frame and then a list of columns. So I import numpy as np. Then I write for col in columns. This is really not important. I don't know why I left it there. While I was playing around, I wrote that code. So yeah, I say for columns in columns, which means for col in columns, which means I am saying for each column that is in the list columns. I don't know if you understand me. For each column that is in the list columns, remember the uCount takes in 2 arguments, a data frame and column names. So data frame and a list containing column names. So for each column name in columns, that is what I'm trying to do here. I'm saying that num should be equals to the data frame subsetting that column and then getting unique. Now .unique is a function you call on a data frame column to get the number of unique, or to get the unique values in that column. That is what .unique is for. So I'm going to do something here. I'm going to convert this to Markdown. Converting it to Markdown means that it is not a code, and it's when you run it, it's not meant to bring out any output. So I want to do this because I would like to show something here. So I'm here. I've converted that to Markdown. We'll come back and convert it to code afterwards. So I want to make use of the .unique function so you understand how it works. So my data is autos, and I want to subset it on the file type. So file type dot unique, then open and close your bracket, then I run. So now after running this dot unique, it gave me an array of the unique values that is contained in file types. So basically what this function is doing is that it's saying for every column it should do this. It should run this code that I just ran, which is the same thing as this code here, because the df now is going to be our data frame, which is autos here. The column is going to, as I said, for column in column. So let's say for the first column is file type, which is now going to be file type. Then it runs the dot unique on it and it returns this. So the next line, which I call if, is what is meant to convert this to a list. Now let me do, I want to, everything I just did up there, let me call this home. Let me go home and call this a is equals to this, right? Then I say from here, I say a dot to list, and I close my bracket. When I run this, it returns a list. Now, so what I'm saying is that after it has called this first argument on each column, the second one is you return this. Instead of returning an array, you should turn it into a list. Because what I want to get is, I don't want to really see what each column contains. So this is very, very important to see it. But what I want to see here is how many distinct values does each column contain. So gas and diesel is what the list contains right now, which means the column, all through the column, it is either going to be gas or diesel, nothing more. So from this to list, now I have a list. The next thing I now want to do is to know the length of the list. So let me call this list B. Right now I want to know the length of B. So the next thing I call is len, and I put in the argument B. Now you can see. So this returns 2. It returns 2. So which means at this point in time, when we get here in our code, the code is going to be returning to us the number of unique values in our data set, in each column of our data set. So that is what is going to be happening there. So we come back here and we can see then lastly it is to print the column, which is the column name, plus the string of types, which is the length, which is the number of unique values each column contains, plus unique values. Don't worry, you see what it outputs very soon. Let me convert this back to code and then I run. After running, it's a function, you don't expect any output. Let me remove this. So after running, it's a function, you don't expect any output. Now I'm calling that function on every column. Remember I called columns there and I am able to see the names of all the columns, so I just copied this and I put it here. So I'm calling that function on every column in our data set. Right, and how do I call this function? I call the uCount, which is uCount, open the bracket, df autos, and column should be equals to columns. Then I run this. After running this, see what I get. It is telling me that symboling has 6 unique values. Normalized losses has 52 unique values. So we are not thinking of converting that to categoricals. Make ID has 22 unique values. I think we should convert that. Aspiration and the likes, you can see. But then looking at fuel type, it has just 2, and currently it is being called a string or an object, which our machine learning algorithm is not going to recognize. And the same thing with aspiration, number of doors, body style, drive wheels, engine location. All these things in our data set are being called object, and the same thing with engine types and number of cylinders. So all these columns we really, including fuel system, we really want to convert them to what? To categoricals. So that being said, I am writing another function to convert each of those columns that we don't want, to convert them to categoricals. Now, this column, how do you convert to categorical? For you to convert a column to categorical, you use the as type category. So basically what I'm doing with this code is I'm saying almost the same thing. It's taking the same argument as what uCount does. uCount takes. So the number of argument takes into argument. The first argument is to be your data frame, and the second argument is to be a list of columns you want to convert to categorical. Right. The reason why we are writing these functions is because if we should start writing lines of code individually, it will take much time before we can cover all the columns. But with these functions, you can actually just input a list of columns and everything will be converted. List of columns you show you want to convert to categorical. Right. So these are part of the insight you get when you do your spreadsheet analysis, because you can see which columns you should convert to categoricals and which you should not convert to categoricals, which you should, and what next step you should take. For example, let's assume that the fuel type has 171 unique values and it is an object. I am not going to convert it to categorical. Now I know that I'll have to do some natural language processing tweaking on my data set to know, so that I can convert these strings to numbers in a reasonable way. That is for another video or for some other time. So basically here, this function here is just to convert every column in columns to categorical. That's it. If you pass in a numerical column, it will convert it to categorical. If you pass in an object type, it will convert to categorical. If you pass it strings, it will convert them to categorical. So you need to be careful and know what you want to convert and pass in the right columns that you want to convert to categorical. Alright, so here is the code. The first line here says for column in column. So now I'm calling df.col, which means I'm calling on every column. I'm calling on the column and I am telling the column to change itself and become a category by calling the column again and changing it to as type category, right? So now it should return the column infos for the list of columns that was imputed into the dataset. So let's see how this works. So after doing that, and also I added something here for those of us that don't know. It's called doc strings. So doc strings are like a way for you to tell somebody else that is going to be using your function how to use your function, because it's your function, right? And you can actually build a whole lot of functions and export it out there for every other person to use. So you tell them how to use your function using this doc string. But then I just wrote some short stories here. You can write something more interesting under your doc string. And if someone wants to check your doc string to know how to use your function, the person can use the help and then calling them of your function into the help. So when the person does that, the person will see whatever you wrote here under your doc string, whatever you wrote within your doc string. So how do you define your doc string? Your doc string comes with sort 3 inverted commas. So that is that. You use that and you're good to go. So that is your doc string, and then we come here. Now I'm trying to use the function I created to convert those columns that I said should be categorical to categorical. So I created a list of columns and I called it columns. And now I'm passing the 2 arguments. The first argument, which is our data frame, which is called autos, and the second argument, which is the list of columns, which I just made here, called columns. Now when I run this, it gives me this output. Now what is this output saying? This output is telling us that it has actually converted all the columns, the list of columns we've given it, to category, and it's now telling us now that symboling is now category, make ID, field type, and every other list and every other column listed here are now categories, as you can see here. So from here we can move on. Now the next thing I would like to do with us is autos.describe. This is a very, very beautiful and important tool to do, a very, very beautiful and important thing to do, because it gives you all the summary statistics of every numerical column in your data set. Now let's look at this. After calling the describe function on our data set, it returns this. So it's giving me the count, that is the number of non-null values in our data set, and it's giving me also wheelbase, the number of non-null. This has no missing value, but this has missing values. You can tell from it that this has missing values, and the likes like that. And that's not all it is telling you. It is also telling you the mean of that column, the standard deviation, the minimum value, the 25th percentile, the 50th percentile, which is the median. Your 50th percentile is your median, your 75th percentile, and your maximum value in that column. So it gives you the minimum value in that column, the maximum value in that column. Now the minimum value and maximum value in the column is very, very important. You should actually look at those, because for example, let's say one of the column is called time, the time it takes for a car to run 100 meters, right? And then you realize that one of the columns that the minimum value in time is actually a negative value, and you know time can never be negative. Time has to be positive. At worst, time will be 0. Time cannot be -1 or -2. So that way, realize that there's a problem with your column. So you should actually look at those minimum and maximum values before you move on. It's very, very important. But right here, I wrote a function because I would like to be seeing for each column specifically their describe function. So I also wrote a function. You can run through it. I put some comments beside each line of code, so we don't waste so much time. You can use the comments to see what I'm trying to do. But then when you try this, and also I did something interesting here. You remember that I said your 50th percentile, that your 50th percentile is the 50th percentile is your median. So here I converted the 50th percentile to median, right? I did that. So instead of it to put 50% here, it's going to be writing median, which is why when I run this code for the column price, it has changed this to median. So, but then moving on from there, right, there are a number of other things you can actually do here. Let me do one last thing before I go. Right, so I said normalized losses as a number of missing columns, which I am going to prove to you right now by doing this. So df df, I put this normalized losses that is NA, right? Oh, why is my algorithm taking, sorry, autos, I remove that. Now it's giving me true, false, true, false, true, false, true, false. But then when I sum this, I don't know if you know, but in Python, if a value is true, it is taken to be 1, and if it is false, it is taken to be 0. So when you take the sum of true and false, true is 1, false is 0. So when you take a sum of it, you get 1. So now for you to know what number of columns is missing here, you just have to add the sum to the is NA. Is NA shows that it is missing. Then the sum shows that you want to add everything up. So when we run this, we get 41. So normalized losses has 41 missing columns. Sorry, 41 missing rows, 41 missing values. So that way you already understand that normalized losses has some issues. You should look into that. And also, I will probably give some tricks on another video on how to deal with your missing columns. You don't really want to drop them, neither do you want to put in the main of the column there or something like that. So right now I'm going to visualization, but visualization is going to be in the next video. So see you in the next video. For now, we're done with this. We'll start visualization, which is also an important part of exploratory data analysis, in the next video. See you there.